Excellent work. Now let's move on to example 2. If I read this, we got the bearings of 2 points on a shore from a boat are 115 degrees and 123 degrees. Now remember, bearings north is 0 degrees and east is 90 degrees. So assuming the 2 points are 855 feet apart, how far is the boat from the nearest point on the shore if the shore is straight and runs north-south? So I got to get myself a little picture here. Again, here's that fabulous boat, and here is your north-south shore. And so the boat, that nearest point would be right here. Let's call it, X. Or no, let's call it something more like P for point. Now I want to know that distance. And all I do know is that if we draw the bearings in here, there's my boat, we have 115 degrees, so 90, just a little more. We have a bearings of about this. We'll call that point A. This is 115 degrees. We also have another bearing of 123 degrees, so that's going to shoot out like this. And we'll call that point B. So that blue line is 123 degrees. And the last piece of information they gave us was that there's 855 feet between A and B. And so our question is, how far are we from the shore? In other words, this distance right here from the boat to point P, let's call that X, how far is that point? Well, notice we got two similar triangles here, or at least two triangles that we can make a relationship with. So I'll call the distance between P and A Y, and I will set this up. Now look at that beautiful right triangle at point P. And I think I'm going to need a little bit of work here to figure out actually what these two angles are. I'd like to know what this angle is right here, because that's part of my triangle. Now 90 minus 115, that's going to be 25 degrees. And this little larger one right here, that's going to be 123 minus 90, so that's going to be 33 degrees. I think that's going to come into this problem somewhere pretty darn soon. So first thing I'm going to do is try to figure out a triangle for my boat to point A to point P, and that's definitely going to be tangent. So the tangent of 25 degrees has to be equal to y over x. And I also have an equation for the other point to point B, which is going to be the tangent of 33 degrees is equal to the opposite, y plus 855 over x. And so you'll see we have two equations where we could make one say y equals, preferably the first one, substitute it into the second one, and we should be able to solve for x, the distance to the shore. So I'm going to go ahead and do that. I'm going to rewrite this first equation to say x tan 25 is equal to y. And now I'll substitute that in and see what happens. So I got tan 33 equals x tan 25 plus 855 all over x. Now bad news, we got two x's in this problem, so we're going to have to turn that into 1. So I'm going to multiply both sides by x for a second. And then that way at least we can try to get our x's on the same side. And so now I'll subtract that other one over, and we have x tan 33 minus x tan 25 equals 855. Now the reason I wanted both those x's together is now hopefully I can factor them out, and as you can see I can factor it out and have tan 33 minus tan 25 equals 855, and all of a sudden this has gotten to be really nice where I can solve for x just by figuring out what 855 over tan 33 minus tan 25 is. And this has gone very smoothly. I will grab Sheila, I will look, we'll grab my calculator, make sure she's in degree mode, which she is, and I'll have 855 divided by, now make sure you get that quantity in the denominator, put parentheses around it, and I get tan 33 minus tan 25, and looks that we are about 4,669.5 feet away from shore. So x would equal 4,669.5 feet. I better read the instructions one more time. They did not ask me to round, so go as close as you like. And now we can tell the captain how far from shore we are. Awesome. That's it for today. Do one more of these, and I'll see you tomorrow.